Here we're going to solve a square root equation that contains two square roots, and we'll end up having two solutions for this equation. Alright, so first thing we want to do is isolate one of the roots. It doesn't matter which one we isolate, so I'm just going to pick the one on the left. And the general idea is isolate a root, square both sides of the equation to get rid of the root, and then isolate the other root, square both sides of the equation again to get rid of the other root, and then solve for x. So we begin here by adding square root of x minus 2 to both sides so that it cancels on the left. And that gives us square root of 2x minus 3 is equal to 1 plus square root of x minus 2. Now we have an isolated root, so we can go ahead and square both sides of the equation. And squaring the square root gives us the insides out, 2x minus 3 equals, and here be careful not to just distribute the exponent of 2 to both of these terms separately. What we need to do is multiply 1 plus root x minus 2 times itself. So we're actually going to have to FOIL it out, and we'll end up with a middle term that we would have lost if we just squared each of these terms separately. So multiplying that out, we get 2x minus 3 is equal to 1 times 1 is 1 plus 1 root, or just root, x minus 2, then plus 1 root x minus 2 again, so plus root x minus 2, and then plus square root of x minus 2 squared. Alright, so that was FOILing out or distributing out the right side. And now we can simplify things a bit. We get 2x minus 3 is equal to, and we can combine these like radicals, 1 plus 1 root x minus 2 plus another root x minus 2 is 2 root x minus 2, plus, and then the square root being squared gives us the insides out, so plus x minus 2. And we can keep simplifying. We can say 1 minus 2 is negative 1, so we get 2x minus 3 equals negative 1, and then just bring down the other stuff, plus 2 root x minus 2 plus x. And now we're ready to isolate the second root, so this root right here. So we can isolate that by adding 1 to both sides of the equation, subtracting x, and we get x minus 2 is equal to 2 root x minus 2. And here we have a couple of choices. Usually what we do is we keep going until the root is completely isolated, which would mean divide both sides by 2. But if we do that in this case, we're going to get x minus 2 over 2 on the left side, and it'll just be messier because we're going to have to deal with a fraction equation. So what we're going to do instead is, at this point, go ahead and square both sides of the equation. So if I square the left and square the right, on the left side I have x minus 2 times itself, so x minus 2 equals, and on the right side, because these two are being multiplied together, the 2 times the root, the exponent can go to each one separately. Or in other words, what I'll be doing right here is 2 root x minus 2 times itself, 2 root x minus 2. And because all of these quantities are being multiplied together, we can go ahead and multiply them in any order we want. So I can do 2 times 2 is 4. And then root x minus 2 times root x minus 2, that gives me the insides of the root, x minus 2. And that's still multiplying the 4, so I put parentheses to show that the entire x minus 2 multiplies the 4. So that's what's happening right here. And you can also think of it as the exponent is distributing to the two factors on the inside. Alright, and that works because they're being multiplied together, they're not being added. Okay, so we can keep going, clear parentheses, and then we'll decide if we solve a linear equation or a quadratic equation after we've cleared things out. On the left side we have x squared Then minus 2x again is minus 4x. Minus 2 times minus 2 is plus 4. That equals, distributing on the right, we get 4x minus 8. And now it looks like we have an x squared term that's not going to cancel out, so we have to solve a quadratic equation. And what we'll do is get this into the equals 0 format, and hopefully factoring will work. If not, then we'll use a different approach. Alright, so first thing we need to do is get these guys over to the left side. We want equals 0 on the right, so we're going to subtract 4x from both sides and add 8 to both sides. And that's going to give us equals 0 on the right. And on the left we have x squared minus 8x plus 12. And then we try to factor it, and this looks factorable, so we'll go ahead and keep solving. So we get x and x, and then factors of 12 that combine to 8 would be 6 and 2. And they're like signs because we have a plus 12, and they combine to a negative, so they're both negative. And now we can say each factor, set each factor separately equal to 0. And that will give us our two options. Either x minus 6 equals 0, in which case x is 6, or x minus 2 equals 0, and that gives x is equal to 2. And that gives us our two solutions. And I'll leave the check for you to do, but you can check each one of these in the original equation, and you'll see that it does come out true in the original equation. Therefore, both of these are valid solutions.